Okay. A couple of years ago, I wrote a textbook, Mobile Codings, but I don't, yeah, do not buy this. Um, that textbook contains uh, actually Xcode Codings has two tracks for user interface developments. One you can use UIKit, which is drag and drop type of application developments. The other one is a Swift UI, Swift user interface, a little more codings. So two tracks available. Till a year ago, I taught the UI kit. So drag and drop, and you can simply connect views and back end the controller codings. But in this semester, we're not going through that direction, but we will do simply the coding itself, which is a Swift UI. It's much easier and much more powerful. The textbook that I wrote covers only the UI kit, which is the drag and drop mode. But in this class, we're going to do Swift UI. Right now, it's not really clear to you guys, right? But you can figure that out sooner or later. Before we get to that tech in depth, so let me start with the general concept of mobile technologies. So mobile technology is kind of infrastructure and protocols and devices that enables wireless communications and mobile computings. You can see the examples of that rely on mobile technologies everywhere these days. You guys heard of the new terminology called Stargate. What is Stargate? This is AI things, AI infrastructure. One of the technologies that this government wants to focus. I think yesterday maybe Oracle CEO is Larry, right? And also OpenAI CEO Sam Altman, and then SoftBank, the investors Masayoshi, right, from Japan. So they all together needs to build a data center. It's not simply typical data center, but it is AI data centers. Okay, so Sam Altman said not simply AI but AGI. You guys know what AGI is? AGI is similar to AI, artificial intelligence. So what is AGI? General, okay. So artificial general intelligence. AI may work, may be feasible if it runs on a specific domain for a specific goal to achieve. So AI is far from what human can do. Human generally can do so much more things than the machine can do, right? Machine is goal-oriented, domain-specific intelligences. So what is the future? Future is more general. So that's what they are trying to say. Something that we can see, this kind of mobile technology these days, not only from your smartphones, but the vehicles as well, right? The vehicles so intelligent. How, for example, Tesla, if you consider Tesla, then how Tesla can be more sensible than the driver? Tesla equipped with multiple cameras, right? Human, the driver has how many cameras physically? We have two cameras, two eyes, right? Somebody has only one eye. Unfortunately, somebody has maybe no eyes, right? Some years ago, I was about to lose one of my eyes, right? Tesla has multiple the cameras running. So while a driver runs the car, Tesla can see a lot more than the driver can see, right? And therefore can react if needed in response to the event that takes place. So, which means that is intelligent, right? Eventually. Okay. So, key components of mobile technologies. First of all, we need mobile devices, smartphone, tablets, wearable. Wearable, the devices becomes available more and more in addition to smartphones. How many of you guys have more wearable devices other than your smartphone? Smartphone always comes with you, right? But in addition to that, some of you maybe watch, right? So watch can come with you. Some of you maybe many others, right? And wireless communication, cellular network, 5G currently, 6G to come sooner or later, Wi-Fi that is available, Bluetooth, and mobile operating systems, Android, iOS. So Android for Android device application. There's operating systems, right? iOS for Apples and some others as well. Mobile technologies, mobile applications, so-called apps. There's a software designed for handheld device. That's something that we want to do in this class. And cloud computing, that sits above all and controlling and receiving and providing some of the resources. So what we do in this class, actually, this cloud computings, you don't have to worry about. I am providing you. So you can access remotely to the cloud that I provide you. Okay. So this mobile apps are not only smartphone mobile apps, but your Raspberry Pi, RPI. So RPI can communicate to cloud computing and your mobile app also. So what you guys need to do is a mobile device, this. And some of, smartphone, number one. And number two, Raspberry Pi. Raspberry Pi. Good. Key features of mobile technology is mobilities. Devices and users can move freely while staying connected. Understandable, right? ubiquitous, available virtually everywhere due to widespread network coverages. So ubiquity is another. You don't have to worry about this. Once you have a device ready, then that means ubiquitous. Personalizations. This is something that I want you to consider when you develop apps for your smartphone. Then how can you make something personalizable? Think about that. Interoperability. This is what we want to do, right? What that means is that your Raspberry Pi can take the data from your environment using sensors. What kind of sensors that you guys need to work on? That we are going to cover next week. Okay. So I'll let you know how many weeks that you need to come to this classroom in person. And then we'll take maybe 3 to 4 weeks at home while we are working on Raspberry Pi. You don't need to come here. So after we cover that Raspberry Pi, then we need to come back here for iPhone apps developments till the end of this semester, which is not bad because the weather is really bad during first few months. The second half of this semester may be okay. So we'll come here more often and regularly. So interoperabilities. So eventually, let me draw here again. So you have here the cloud. In our case, I'm going to run Google Cloud. Google Cloud. So in the back end, we have a database and also the middleware. I use PHP middleware. So you don't have to worry about this database issues, PHP middleware. Simply, I will let you know which program that you need to use to access. Okay. You have here Raspberry Pi, okay? Raspberry Pi has Wi-Fi communication available. So on your, for example, through the router, it access to. Would you be able to open the door for you? So this is a Raspberry Pi. On this Raspberry Pi, you guys can see there's some pins, right? We call that GPIO pins. So general purpose input-output pins. Through this GPIO, so you have here a sensor, some of the sensors. I want to look at this. So you guys can see. Let's see. This is the Raspberry Pi that you can see, all right? This is a Raspberry Pi, and we have the pins here. 40 pins available. In the previous semester, we never used the pins, right? But in this semester, we use pins. So some pins that you can connect to the sensor. This is a sensor. This sensor is sensing humidity and temperature together. So you need to run your program on this Raspberry Pi. I have here SD card. This is a SD card, right? So I want to plug this in this SD card. So, so in this SD card inside that you have to the program and run that program. That program needs to not only the sensing this data as the sensor data, it needs to communicate to the cloud server. So it push over about the sending the sensor data. This Raspberry Pi is not simply the sensing the data, but also actuating the data, some of the actions possible. Okay, some of the pins to use to run motor, for example, motor. So motor can make some of actions, right? Motor is very, very important in most of the cases that you can do. So in this case, for example, this is a sensor, but some of the, let's say, some of the actuator, okay? This actuator may start nuclear plant, may start unmanned vehicles, okay? Or door lock. Lock can be unlocked by turning the motors, so the lock can pull back some of the lock device from the door hinges. So sensing and actuations both are possible. So they are communicating with this cloud servers. So this part that we are going to practice in maybe next 4 weeks, 4 classes. And meanwhile, we have here iPhone. Okay, iPhone has also Wi-Fi, so that you can communicate with this cloud server. And some of the view and some of the control and based on some of the model is nothing but data models, okay? For example, if you want to handle login ID and password, those two components needs to be defined. That is data models. Okay, so based upon these data models, you need to control to display on the view. Okay, so that is 3 components is a major component for the smartphone app developments. So model, control, and view. You can see this clearly while you are developing the smartphone apps. Wireless sensor services. This is the mandatory components for mobile technologies. Although we do not really consider this much in this class, right? I don't think computer science master's program provides any technical the courses about wireless sensor networks. So it is distributed sensors. That sensor can monitor physical and environmental conditions and then transmit the data wirelessly to central system. That is something that we can say the Google Cloud. Wireless sensor networks has a sensors, communications, basically, okay? If you have a multiple Raspberry Pis to deploy, then we need to think of nodes. But in our class, we don't do, because we have only one single node. So each student needs to have one single node. For your project, if you want to do multiple different nodes, if you have multiple Raspberry Pis, so one Raspberry Pi may sense one kind of environment. The other Raspberry Pi may want to sense another. And those two sensed data needs to be collaborated. Then you may need to do some of those. Or one may do the monitoring only, the other may be action to take. Okay, whole different things. Communications, also we don't need to worry about much, right? We simply rely on Wi-Fi, not even Bluetooth, BLE, or Z-Wave, or Zigbee. But those are the terminologies, the news are, it's not really new. It has been old, right? Maybe a couple of decades in the market. Z-Wave is a little bit new, maybe 5 years old. Zigbee maybe 20 or 30 years old. Bluetooth, again, 30 or 40 years old. Wi-Fi, similar. At least I want you to be surprised when you hear these things. So these things are some of the communication protocols. Although you guys do not know yet much, but sometimes you need to configure Bluetooth. You need to sometimes configure Wi-Fi, right? Gateway or cloud services. Applications for wireless sensor services, we need to have smart homes. Well, this is a kind of applications. Smart homes. Lighting systems, heatings, and securities. Then you can set up IoT devices. One of the IoT devices internally built in is Raspberry Pi. Not like these big ones, but even the Pico size, or even very small, customized sizes available. All such things can be called microcontroller. Microcontroller. When you have a multiple microcontrollers, and if you want to make a big service from each such microcontrollers, then those services can be called microservices. Microservices. Okay? Some of you guys understand that. Healthcare. Patient has some wearable sensors. Right? Environmental monitors, agriculture, industrials, so many things available. Those are the applications. So now we need to do sensor and mobile tech needs to be integrated. We call that Internet of Things. So mobile devices often act as gateways to control and monitor wireless sensor networks. These days, the homes not simply empty even though humans are not living, but homes equipped with a lot of cameras and sensors built in, therefore can be controlled from outside, right? So your aircon and heating systems can be controlled from your
Lighting.
lighting as well, from your smartphone apps, right? So while you are not at home, you can also control. You can control electric control panels electronically. Gas supply may be controlled. Data collection and analysis. Data can be collected from sensor, right? It can be analyzed on cloud, because cloud is a lot more powerful in computing, so it needs to be analyzed there. And then it can be accessed by mobile applications, right? Future trend in mobile technologies and 6G, of course, is coming soon, or beyond. Edge computing is not main computing. There's an endpoint somewhere. We call that edge. Well, somebody said a few years ago, they said fog computing as opposed to cloud.
What is fog computing?
There is nothing but edge computing, but different names. They name it differently. Edge, so processing data closer to the source. So sources are widespread, right? All over the world, like a fog. When fog comes, covers all around. So, so computing may be made in each endpoint devices. We call that edge computing. One of the typical edge computing is Raspberry Pi. Okay, microcontrollers. AI and machine learning already came, will be extended, will be enhanced much, much more. And energy harvesting sensors. So usually battery is the big issue, right? This Raspberry Pi can be supplied. This Raspberry Pi does not need a 100 volt power supply. It needs, I think, 12 volts to stabilize, or worst case, 5 volts also possible, but usually 12 volts. If you want to do multiple actions on your Raspberry Pis. But battery is really the issues. So industrial revolutions, you can consider from the first industrial revolutions. Currently, we are on the fourth industrial revolutions, which is based on cyber physical systems. Cyber physical systems. What is a cyber physical systems? There is a physical system, but it can be controlled by in cyberspace, which means remotely. From your cell phones, you can control drones, right? From your smartphone, you can control motorboats on the sea. You can control your vehicles. That is a cyber physical systems. Why cyber physical systems has lots of threats and risk? It is because physical systems can be controlled remotely in cyberspace. Not only you guys can control, but also attackers can control my physical systems. Your physical systems, you can think of your vehicle, or you can think of your home. If it is already digitally connected, then is your home is secured? Yes, it is secured, unless that control is acquired by an attacker. If attacker has the same control as you do, then your physical system is not anymore yours, right? It can be owned by, controlled by anyone else. So security is important when it comes to cyber physical systems. So resolutions. The first industrial revolution is mechanizations, machines developed. I want you to think about this. In 1760 to 1840, probably technology is steam engines, textile manufacturing. As far as I know, this revolution was initiated from cotton clothing development, textile industries, while United Kingdom occupied Indian land, where there are lots of cotton fields available, and then Indians, the country India leads cotton textiles. Meanwhile, United Kingdom has only wool. Wool comes from animals, right? So wool textile requires a lot of sensitive management. The cleaning is not simple. If you compare that with the cotton shorts, there's a washable, right? Wool shorts, you need to do, I think that is oil-based cleaning systems. So lots of those difficulties available. So UK, there's a historic facts. I'm not going to do it in detail, but anyway, so United Kingdom developed the machineries that can make cotton shorts. The materials are imported from India in cheap price, and then they make clothes, and then they sell the clothes to India in higher price. That's what happens at the time. The second industrial revolutions, that is electrical revolutions. So technology is electric power and internal combustion engines that can make a high temperature, and then telegraph, telephones, and radio communications available from the second industrial. Third industrials, semiconductor, microprocessor, personal computers developed, and the World Wide Web was developed in this time period till 2000. So robotics and all the AI systems introduced. And now, starting from 2000, we are in cyber physical system with AI. So artificial intelligence and machine learnings. Artificial intelligence a little bit in more generalized mode. So we call that artificial general intelligence, AGI. And then some of the security issues, decentralization, IoT, autonomous vehicles, smart devices. Autonomous and smart device, IoTs, they all need smart application programs. Without smart application programs, they are not really smart at all. Right? Hey, Amanda.
I've come to see you. Oh, you're mad, of course. That's exactly what the issue is.
I'll finish this maybe
Oh, no,
in
I just want to see how
30
you have
minutes.
it connected. Hello, Professor.
Right.
I just want
Hi.
to see where the connection is running.
Oh, right now here. If we connect this from my laptop, MacBook,
Yeah, the left screen's gonna go.
left one's is not. So we have only two terminals running. That will go quick.
So I
And
wonder
then
why the
that-
right one started going out, which is weird because it wasn't doing that
Yeah.
yesterday. That's okay. I just needed to see.
That's why I connected this, and they are connected through the Zoom. A little bit of the things.
Yeah, I just needed to see.
All right. Some of the interruptions from IT guys.
So did they propose a solution, or did
Which one?
Did they propose a solution, or did they just take a look?
They looked at the issue this time. No, there's no solutions. They looked at this issue 2 years ago. Okay, potential fifth industrial revolutions. Okay, that's a sustainability and human-centric innovations. Let's look at this. Emerging trends suggest a shift towards integrating advanced technologies with a focus on sustainability, ethics, and human well-being. It's a lot of good words, right? That's what we want, really. Someone said, oh, because of this fast enhancement of the new technologies, someone said, oh, I do not want to learn in the future. This is enough. Enough is enough. Meanwhile, some other guys says, like us, we are looking forward to the integrations, advanced technologies with the focus on something that has been missed so far, right? Which is sustainability, ethics, ethical issues, and then human well-beings. So that we have here widespread use of green technologies, enhanced collaborations between human and machines, focus on reducing inequalities and promoting global well-being. Case of the Tesla FSD. which is a full self-driving. This is one of those, right? Full self-driving has been enhanced, has been it can replace sooner or later the human driving. They keep updating full self-driving. So now, as if I compare that to 2 years ago and now it's much reliable and sensible and better than human driving. So why it is that big advantages right now is the sensor data acquisitions. So we have cameras, radar, ultrasonic sensors, GPS. This is some of the internal measurement units, like monitoring vehicles dynamics, like accelerations, orientation, and velocities, and maps. Sensors are available for each of these categories if you are interested in. Okay. There's an acceleration sensors and orientation, so-called gyroscopies sensors. Some of the tiltings can be sensed, and velocities as well. Data flow. Sensors continually capture the real-time data, sending it to Tesla onboard computer for processing. So all those things together can enhance FSD. And data fusion and processing. And neural network processing has been used, but in this class we don't do anything about the neural network. Decision making, not much in this class. Actuation, here somewhere is sensing, right? From sensing to actuation. In between, we did some of those works, okay? If you sense some issues, then you have to make a proper, accurate actions. So actuation is needed. So in your project, if you want to work on actuation, then you have to study early. I have experience on sensors and actuations, so you can ask me individually. We don't do much about this actuation and sensor itself. Continuous feedback loops, connectivity. Okay, so this is the last slide. Sensing and actuation. Two things will be covered in this class. Learning, you can learn something from somewhere. We don't do here. We have a limited time, right? This itself is much to us.